All right, in this video, we're going to talk about section 4.6, dealing with optimization. And in this video, we're going to express a given quantity as a function, optimize the product of two numbers, solve area and perimeter optimization problems, and solve applications involving optimization. All right, now, in this section, we're going to be using calculus to solve optimization problems, and those are problems that involve finding the absolute minimum value or the absolute maximum value of a function. And common optimization problems involve finding the area and perimeter, maximizing revenue and profit, and inventory control. Okay, so what I have here on the first page is just a procedure of solving optimization problems. Here's just a strategy of doing just that. Number one, you're going to introduce variables. You're going to look for relationships among the variables and construct a mathematical model of the form maximize or minimize f of x on the interval I. Okay. Then the second step would be to find your critical numbers of the function f of x. That means you'll have to find the first derivative, set that first derivative to be equal to 0, and then find out what your critical numbers are by solving for x. Then number 3, you're going to use the procedures back in section 4.5 when we were dealing with absolute maxima and minima to find the absolute maximum or minimum of the function f of x on the interval I and the numbers x where this occurs. Okay, so you might want to refer to the video that I did for section 4.5 dealing with absolute maxima and minima, because we'll be dealing with that in this section for optimization. And then finally, step number 4 is to use the solution to the mathematical model to answer all the questions asked in the problem. Okay. All right, so what we're going to be doing today is just looking at some examples that deal with optimization, like this first example. Let's say I want to express the given quantity as a function f of x of one variable x. And here I have the product of two numbers x and y, whose sum is 14. Okay, so now, word product does mean multiplication, so that means that the product of the two variables that we'll deal with the product of two variables is x, y, x times y. That's a product of two variables written in that form, x times y. And then we need another equation because it says here whose sum is 14. So that means if x is the first number and y is the second number, then the equation for the sum of the numbers, the equation sum of the two numbers is this equation, x plus y equals 14. Because sum does mean add the two numbers together in this case. So x plus y equals 14 is the other equation. All right, now the next thing I'm going to do here is I'm going to take that equation for the sum of x and y equaling to 14, and then I'm going to solve it for y. So I'm going to solve the sum equation y. So the x plus y equals 14. If I solve for y, I need to subtract x on both sides. That would tell me that y is equal to 14 minus x. So solve for y, I have y is equal to 14 minus x. And then I'm going to take that y equal 14 minus x. Well, that 14 minus x will be substituted for the y in the product equation. Okay? Because that product equation was xy. So I'll write that down. And that's equal to, bring over the x, and then I'm going to substitute the y with that 14 minus x. Okay? And that will be as far as I will go with that problem. So that x times the quantity 14 minus x represents what f of x is. X times the quantity 14 minus x. So that would be the quantity as a function f of x in a single variable. And that is what they're looking for. Go ahead and box that in as the answer. Okay. All right, let's look at example 2. Then we're going to express the given quantity as a function f of x of one variable x. And that's this: the perimeter of a rectangle of length x and width y that has an area of 214 square meters. Okay, now there are two things you do need to know. The perimeter of a rectangle. That's 2 times the length. It's spelled length. 2 times the length plus 2 times the width. Now in Canvas, I will be posting a formula sheet that you can use to help you solve some of these problems. But one of them will be finding the perimeter of a rectangle. That would be 2 times the length plus 2 times the width. Also, you need to know that the area of a rectangle that's just simply the length multiplied by the width. You do need to know what a rectangle looks like, by the way, visually. It does have a length, which I'm going to call it L, and W will be your width. Okay? So in this case here, the perimeter of a rectangle, which I'm going to label as P, has a length x and a width of y. So that perimeter will be 2 times the length, or 2 times x, plus 2 times the width, which will be 2 times y, because x is the length and y is the width. And the area of the rectangle, A, is equal to length times width. Well, that's x times y. And we're told that the area there's an area of 214 square meters, so your A, I'm going to replace that with 214. So 214 equals x times y. Now, what I'm going to do here is take the area equation right here, 214 is equal to x times y, and I'm going to go ahead and solve that equation for y. So to get y by itself, I'm multiplying it by x. I'm going to go ahead and divide both sides by x. So that means y is equal to 214 divided by x. Now the reason why I did that, because I want the function to be in terms of x. My f of x function has to be in terms of x. And then I'm going to take that 214 over x, which is what y is, substitute it for the y in the perimeter equation. So if my perimeter, I'll rewrite it here, is equal to 2x plus 2y, then that means 2x, bring that down, plus 2 times the the y is going to be 214 over x. So it'll be 2 times 214 over x. And then we'll simplify that. So that means I have 2x plus, and this is like 2 over 1 times 214 over x. 2 times 214 would be 428 over x. And I'm going to let this be my f of x function here. So that means f of x will be equal to 2x plus 428 over x. Okay? So that would be my function f of x in a single variable. F of x equals a 2x plus 428 over x. Okay. All right, let's look at this next example. Well, we're going to find two numbers whose sum is 10 and whose product is a maximum. Two numbers whose sum is 10 and whose product is a maximum. So in this case, I'm going to let x be the first number. And y equal to the second number. So two numbers whose sum is 10, as an equation, that would be x plus y equals to 10, because the word is means equal. And the product has to be a maximum. So we're looking for the product of the two numbers, x and y. All right, so what I'm going to do here is take that x plus y equal 10 and solve that equation for y. So I'm going to move the x over by subtracting x on both sides of this equation. So that means I'll have y is equal to 10 minus x. And then take that 10 minus x, which is what y is equal to, substitute it for y in this expression right here, x times y. So this means x times the y, which is 10 minus x, because I'm writing that in a single variable. So x times y in this case will be, if I distribute the x over the 10 minus x, this will be x times 10, or 10x, minus x times x, which is x squared. So what's on the right is what f of x is going to be. 10 minus 10x minus x squared. Okay. All right, now, here's where I find my critical numbers by taking the first derivative of f of x. So here, f prime of x, yes, the derivative of 10x will be 10, minus the derivative of x squared is 2x. And then we take that f prime of x, set that equal to 0, and find out what our critical numbers are. So here, 10 minus 2x would be equal to 0. And then if I subtract 10 on both sides, I'm going to get negative 2x equals negative 10. Divide both sides by negative 2. X is equal to 5. So that means my critical number is going to be x is equal to 5. Now, here's what I'm going to do here. That f prime of x, which is 10 minus 2x, let's find the second derivative, f double prime of x. The derivative of 10 will be 0. The derivative of negative 2x will be negative 2. Okay. Now, if I replace the x with 5 in f double prime of x, that's my second derivative function, it's still going to be negative 2. And If it's negative for the second derivative, that means I have what they call an absolute maximum or local maximum. But since I only have one critical number, that critical number will represent the fact that I have an absolute maximum. So here I have an absolute maximum here at x is equal to 5. So in this case here, if x is equal to 5, then that means I can find out what y is, which is going to be using that 10 minus x, because that's what y is. Because y is 10 minus x, and that would mean 10 minus 5, which is 5. So here x is equal to 5, and y is equal to 5. Those are the two numbers where the sum of the two is 10. The product will give me a maximum. Okay? All right, here's another example. Let's say I want to find, in this case, two positive numbers. Two positive numbers whose product is 85 and whose sum is a maximum. We're finding two positive numbers whose product is 85 and whose sum is a maximum. Okay, so again, I'm going to let x be the first number. And I'm going to let y be the second number. All right, now, two positive numbers whose product is 85. That means x times y, the first number times the second number, must equal 85. And then we want the sum to be a maximum. That's the sum of the two numbers, x plus y. Well, let's do this. Take that x times y equal 85, solve that equation for y. Okay, let's solve this equation for y. So we're multiplying by x, and that means we need to divide both sides of the equation by x. So it'll be y is equal to 85 divided by x. And then I'm going to take that y, which is 85 over x, substitute it for this y in the expression x plus y. So this means I'm going to have x and then plus the y, which is 85, over x. And this x plus 85 over x will be what f of x will be. X plus 85 over x. Now I'm going to write this using negative exponents here. So I'm going to bring down the x plus, bring over the 85. Now if I pull the x out of the denominator, it'll be x to the negative 1. Because what I'm going to do here is take the first derivative so that I can identify my critical numbers here, if there is one. So now, let's take the first derivative. The derivative of x is going to be 1. The derivative of 85x to the negative 1, if I bring the negative 1 down, multiply by the 85, I have minus 85. Copy the x over to the 1 less power. That's negative 1 minus 1. That would be negative 2. And then I can write that using positive exponents as 1 over the 85 will be on top, the denominator, the x will be in the denominator to the positive 2 power. So f prime of x will be 1 minus 85 divided by x squared. Then the next step would be to set, in this case, f prime of x to be equal to 0. And then f prime of x is 1 minus 85 over x squared equal to 0. Now what I'm going to do here is multiply each and every term in that equation by x squared. The left side will be multiplied by x squared, the right side will be multiplied by x squared. So x squared times a 1 will be x squared minus x squared times 85 over x squared. The x squareds divide out. You'll be left with just 85 equals 0 times x squared will be 0. All right, now to get x squared by itself, I'll need to add 85 to both sides. So that means I have x squared is equal to 85. And then solve for x, I have to take the square root on both sides, and I must include the plus or minus symbol. So that means x will be just plus or minus, and I'll leave that as the square root of 85. So that means I have two possible solutions. X is equal to the square root of 85, and x is equal to negative square root of 85. However, the problem does mention that I need to find two positive numbers. And in this case here, one of them is negative. So I need to eliminate that negative square root of 85. So we know what x is, the square root of 85. All right, now we need to check to see if it's an absolute minimum. Well, for that to happen, let me take that I'll just write this as f prime of x is equal to 1 minus 85 x to the negative 2. I'll take that and find the second derivative. Okay. So f double prime of x is this. The derivative of 1 is 0. The derivative of minus 85x to the negative 2, if I bring the negative 2 over, multiplied by minus 85, it'll be a positive 170. Copy the x over to the 1 less power, it would be negative 3. So f double prime of x will be 170x to the negative third power. Or I can write that as 170 over x cubed. And then substitute, since x is equal to the square root of 85, I can just substitute that x with the square root of 85. So this is 170 over the square root of 85, and that's cubed. But would that really matter if I simplify this? Because if I was to do this in the calculator, 170 divided by, and then in left parentheses, second x squared for the square root of 85, close your parentheses, and then I'm going to cube it. It's going to end up being a positive number. Okay? So my second derivative ended up being positive, with f prime of x being 0, so that means I have an absolute minimum. Okay? Refer to the second derivative test that I talked about back in section 4.5. Absolute minimum. Okay? So that means with x being the square root of 85, I can go ahead and find out what y is. Because here y is 85 over x. Replace the x with the square root of 85, so it'll be 85 over the square root of 85. Now here what they want you to rationalize the denominator. And they want you to do that by multiplying the numerator by the square root of 85 and the denominator by the square root of 85. So here you're going to have 85 times the square root of 85 over the square root of 85 times itself. It eliminates the radical. And notice I can divide out the 85, so that means that y will have to be equal to square root of 85. So that means the two values, or the two positive numbers whose product is 85 and whose sum is the maximum, will be this. X will be the square root of 85, and y will be the square root of 85. Okay. Right. Here's another example. Let's just trying to do as many of these optimization problems here. In this example, we're going to find the dimensions of a rectangle with an area of 64 square feet that has a minimum perimeter. A minimum perimeter. All right, so let's look at what we have here. We're going to let x equal the length, and I'm going to let y equal the width. Now, we know that it has an area of 64 square feet, so the formula for finding the area of a rectangle is length times width. So A is equal to x times y. And our area is 64 square feet. That's given to us, so I can just replace the A for the area with 64. So I have 64 is equal to x times y. And a minimum perimeter, well, the formula for finding the perimeter of any rectangle is 2 times the length, and the length is going to be x, so that's 2x, plus 2 times the width, which is y. Now that area formula, A is equal to, 64 is equal to x times y. I'm going to go ahead and solve that equation for y, meaning I need to move the x over to the other side. Well, y is being multiplied by x. Let's divide both sides of the equation by x. So here, this will be y is equal to 64 divided by x. And then, since y is equal to 64 over x, we'll just substitute it for this y in the perimeter formula. So that means I'm going to have p is equal to 2x plus 2 times the y, which is 64, over x. Then p is equal to, let's see, bring down the 2x, multiply 2 over 1 times 64 over x, that would be 128 over x. Now, I also can write that using negative exponents as 2x plus 128 x to the negative 1. And the reason for that is that I'm going to find the derivative of that perimeter formula. So p prime, if I take the derivative of 2x, that will be 2, so p prime would be equal to 2. And then if I take the derivative of 128x to the negative 1, bring the negative down, multiply it by 128, it'll be minus 128. Copy the x over to the 1 less power, negative 2. And I also can write this using positive exponents. 2 minus 128 over x squared. Now the next step would be to set that first derivative, which is p prime, set that to be equal to 0. So here's what I'm going to have. 2 minus 128 over x squared equal to 0. And then the next step would be to get rid of that x squared in the denominator by multiplying both sides of the equation by x squared. So now if I do x squared times the 2, that'll be 2x squared minus x squared times the 128 over x squared. The x squares divide out, I'll have 128 equals to 0 times x squared, which is 0. And then to solve for x, I first have to add 128 to both sides. So here you get 2x squared is equal to 128. Take that x, divide both sides by 2, you'll get x squared is equal to 64. And then take the square root on both sides and include that plus or minus symbol. That would mean x is equal to plus or minus 8. I would have x equals 8 or x equal negative 8. But I can't have a length being negative. Lengths are never going to be negative, so here I need to eliminate that x squared equal negative 8. So here, it will just be x is equal to 8. Now, to verify that I will have a minimum, I need to take the second derivative, which is p double prime. So I'm going to use this right here with the negative exponent in it and find out what the second derivative will be. The second derivative of 2 is 0. Well, the derivative of 2 is 0. The derivative of minus 128, x to the negative 2, if I bring that negative 2 down, it'll be negative 2 times the minus 128. That will be 256. Copy the x down to the 1 less power. And I can write that using positive exponents. So it'll be 256 over x to the 3rd power. So now p double prime of 8, because x is equal to 8, would be this, 256 over 8 cube. And I'm going to do that in the calculator, because I think this is going to end up being a positive number anyway. 256 divided by 8, then we cube that, will be 0.5, which is positive. Since my second derivative is positive, that tells me I have a local minimum. However, I only have one value of x that's a critical value, so that means I will have what they call a absolute minimum. Reason being is because I only have one critical number, x equals 8. So the absolute minimum will be at x is equal to 8. So that means that my length is x is equal to 8. The width, which is my y, that's going to be 64 over x. So 64 divided by 8 is 8. So x equals 8, y is equal to 8. Those are the two, that's the dimensions where the area is 64 square feet. The perimeter will be a minimum. All right, now let's look at a problem that has a maximum area in it, like this one. Here we're going to find the dimensions of a rectangle with a perimeter of 148 feet, and it has a maximum area. So here, again, I'm going to let x be the length, and y be the width. Now, the perimeter of any rectangle, of course, that's p is equal to 2 times the length plus 2 times the width. But, of course, we're dealing with x and y, so it'll be 2 times x plus 2 times y. And the area, maximum area, means that A will have to be x times y. Now, what I'm going to do here is take that perimeter formula. Now, the perimeter, of course, is 148. So let me go ahead and replace the p with that 148. And that would be equal to 2x plus 2y. And then we can solve this equation, let's say for y. So that means I need to move the 2x over to the other side by subtracting 2x. So if I subtract 2x, that will mean I'll have 148 minus 2x equals 2y. And then to get y by itself, I'm multiplying it by 2, so I need to divide both sides by 2. That would mean y is equal to 148 minus 2x over 2. And since I know that 148 is divisible by 2 and 2x is divisible by 2, I can do this. Take 148, divide that by 2, that will be 74, minus 2x divided by 2 would just be x. Okay, so y would be equal to 74 minus x. And then I'll take that 74 minus x, which is what y is, and substitute it for y into the area formula. So that means I'm going to have this. A is equal to x times, the y will be replaced with 74 minus x. And then if I distribute that x over the 74 minus x, that will be 74x minus x squared. So my area formula will be equal to 74x minus x squared. Here I'm going to take its first derivative of this area formula. So that means a prime would be this. The derivative of 74x will be 74, minus the derivative of x squared would be 2x. So I have 74 minus 2x. And then I'm going to set a prime to be equal to 0, that first derivative. So that means 74 minus 2x is equal to 0. And if I subtract 74 on both sides, that means negative 2x is equal to negative 74. Then divide both sides by negative 2. That means x is equal to 37. So I know my length is going to be 37. But to verify that I do have a maximum area, since a prime is 74 minus x squared, let's find out what a double prime is going to be. Now I'll write the a prime to be equal to 74 minus 2x. And then a double prime is going to be this. The derivative of 74 is 0. The derivative of negative 2x would be negative 2. And if I replace the x with 37 in this second derivative function, a prime of negative 37 would just be that constant negative 2, which is, of course, negative. That tells me, since my second derivative is negative, I do have a local minimum, but I only have like one critical number, so it will be automatically the absolute. And it should be absolute maximum, because that second derivative came out to be negative. Okay, so my length, which is x, that's 37. The width was y is equal to 74 minus x. That would mean 74 minus x, which is 37, ends up being 37. Okay, so the length in this case is 37 feet. Width also 37 feet. Those dimensions are the dimensions of a rectangle with a perimeter of 148 feet and it has a maximum area. Okay. All right, next page deals with a company. It manufactures and sells X cell phones per week. The weekly price demand And cost equations are given below, which is P is equal to 600 minus 0.1x. That would be your price demand equation. And your cost function, C of x, is equal to 15,000 plus 130x. And of course, x is the number of cell phones per week. Here's the two-part question. What price should the company charge for the phones, and how many phones should be produced to maximize the weekly revenue? And also, they want to know what is the maximum weekly revenue. So here in the homework, they're giving you the question with the answers that, well, answer boxes that you need to fill in. So we're going to start with part A. We need to find out what the revenue is going to be, because we got the price up here and the cost. Let's find out what that revenue is going to be. If you recall, your revenue, R of X, is equal to P, which is the price, times X. And that's going to be the number of cell phones per week. The price times the number of cell phones, which is X. That's this formula, P times X. And the price there is 600 minus 0.1x times X. Now, if you distribute the x over the 600 minus 0.1x, you'll get 600x minus 0.1x squared. That will be your revenue function. Now, let's go ahead and take the first derivative if we're finding a maximum weekly revenue. So R prime of x will be this. The derivative of 600x will be 600 minus the derivative of 0.1x squared. Bring the 2 down, multiply by 0.1, will be 0.2. Copy the x over to the 1 less power, so it'll be 600 minus 0.2x. And then set that R prime of x to be equal to 0. That's the derivative of your revenue function. So in this case, 600 minus 0.2x equal to 0. And if you want to, you can subtract 600 on both sides because you're going to have to solve for x. So that means negative 0.2x is equal to negative 600. And then divide both sides by negative 0.2. That means x is equal to 3,000. That you can just type into the calculator yourself. Find out, do negative 600 divided by negative 0.2, you'll get 3,000. So what that means here that the company should produce, and I'm going to need to bring this back up a bit, the company should produce 3,000 phones. Now, we can verify that by taking the second derivative here. Okay. So R double prime of x is this. Take that first derivative and get a second derivative from it. The derivative of 600 is 0. The derivative of negative 0.2x will be negative 0.2. And then if you replace that x here with 3,000 in the second derivative function, you'll still end up with the negative 0.2. And here is negative, so that means we have an absolute maximum. It would be a local maximum, but since we're only dealing with one x value, one critical number, we have an absolute maximum. So now the other part of that is what would be the price? All right, our price function was up here. 600 minus 0.1x. And I'll go and rewrite that down here. P is equal to 600 minus 0.1x. And here that x was 3,000, so we'll do P is equal to 600 minus 0.1 times 3,000. And this will give us, let's see, 600 minus 0.1 times 3,000, which will be 300. So, to answer the other part, the company should produce 3,000 phones each week at a price of $300. So that goes here. And now the maximum weekly revenue is going to be how much? So if our R of X function is this right here, that's 600X minus 0.1X squared, which I will rewrite. R of X is equal to 600X minus 0.1X squared. Then that means R of X, and X is 3,000. So everywhere there's an X, we substituted with 3,000, so it'll be 600 times 3,000 minus 0.1 times 3,000. And that quantity, that amount will be squared. And I'm going to do this in the calculator. So 600 times 3,000, 600 times 3,000 minus 0.1 times 3,000. I'm going to close parentheses and square it. That would mean 900,000. So we're talking about a revenue of $900,000. So the maximum weekly revenue, if we go back up here, is $900,000. And notice that I put two zeros behind the decimal point because it does say round to the nearest cent as needed. And that's what they're going to be looking for when you type in your answer in my math lab. Okay? So all of this represents part A. And if you want to, you can pause the video to try to write as much of this down. All right, now part B. What price should the company charge for phones, and how many phones should be produced to maximize the weekly profit? And what is the maximum weekly profit? So in part B, now there is a previous video, videos from back in chapter 2 dealing with profit function, revenue function, and cost function. To find the profit, you take the revenue minus the cost. Profit function P of X is equal to the revenue function R of X minus the cost function C of X. And in this case, to find that profit function P of X, your revenue function was, in this case, 600X minus 0.1X squared minus the cost. And back up here, the cost function C of X is 15,000 plus 130X. $15,000 plus 130X. Okay? And notice I put that 15,000 plus 130X in parentheses because I'm subtracting the whole cost function from the profit function. Now let's simplify this a bit. All right, so this will be P of X is equal to, bring down to 600X minus 0.1X squared. The negative makes the 15,000 minus 15,000. The negative makes the plus 130X minus 130X. x. And then we can combine some like terms here. Let me put that negative 0.1 x squared in front. 600x minus 130x, I come up with plus 470x. And then minus 15,000. So that's what your profit function will be. Negative 0.1x squared plus 470x minus 15,000. Now let's go ahead and take the first derivative of this. So here p prime of x would be, bring the 2 in front of the negative 0.01, multiply, you'll get minus or negative 0.2x, plus the derivative of 470x will be 470. The derivative of minus 15,000 would be 0. So that's your first derivative of the profit function. So to find our critical number, we're going to set p prime of x to be equal to 0. So p prime of x equals 0, which is going to be negative 0.2x plus 470 equal to 0. To solve for x, we first subtract 470 on both sides. So negative 0.2x is equal to negative 470. Divide both sides by negative 0.2. You'll get x is equal to 2,350. That's going to be our critical number here. Now, let's take that p prime of x function and find out what p double prime of x is. So if p prime of x is negative 0.2x plus 470, then p double prime, the second derivative, would just be the derivative of the first. The derivative of negative 0.2x will be negative 0.2, and the derivative of 470 will be 0. So if I substitute the x with that 2,350, I'm still going to end up with 0.2, negative 0.2. And it is negative, so that tells me I do have an absolute maximum. And I can say absolute maximum because I only come up with one critical number, 2,350 for x. All right, so now let's go ahead and find out what price should the company charge for the phones. Well, that price function is at 600 minus 0.1x, so go down, p is equal to 600 minus 0.1x. So the price there will be 600 minus 0.1 times 2,350, end up being 600 minus 0.1 times 2,350. Here I get 365. So the company should charge $365 as a price. And let me go ahead and fill in the rest of Part B. The company should produce, that was the critical number, 2,350, 2,350 phones, each week at a price of the 365 that I came up with. So I'll go ahead and fill that in. And then we can go ahead and find out what the maximum weekly profit is going to be. Okay, so let's look at that profit function up here. Negative 0.1x squared plus 470x minus 15,000. I'll rewrite that. This is what we'll use to find out what the maximum weekly profit. So here that critical number was 2350, so we'll substitute each x with 2,350. So I have negative 0.1 times 2,350, and that's squared, plus 470 times 2,350 minus 15,000. So negative 0.1 times 2350, and that's squared, plus 470 times 2350 minus 15,000. Oops. Let me go back. All right, I need to delete a 0 for 15,000. There we go. Here I get 537,250, and this will be in dollars. So that means that the maximum weekly profit, if I go back up here, would be $537,250. Notice I'm putting 2 zeros behind the decimal point, because they did say here round to the nearest cent as well. Okay. So all of this is part B. And again, feel free to pause the video if you need to write some of this stuff down. Okay, let's look at example 8. It says here a deli sells 640 sandwiches per day at a price of $8 each. And here's a two-part question. In part A, a market survey shows that for every 10-cent reduction in the price, 20 more sandwiches will be sold. How much should the deli charge in order to maximize revenue? All right, we'll start with that, and then we'll go into part B. Okay, so in part A, we're going to let X equal to the number of 10-cent reductions in price. Because it says here for every 10-cent reduction in price. So we're going to find out how many 10-cent reductions in price we need. So X will be the number of 10-cent reductions in price. All right, now it said the deli sells 640 sandwiches per day at a price of $8. All right, let's deal with the number sold, or the number of sandwiches sold at X times the number of 10-cent reductions. That will be the 640 sandwiches that they sell. And in this problem, part A, they're saying 20 more sandwiches will be sold. That would be plus 20 times the number of 10-cent reductions in price. 640 plus 20x. Okay, now the next thing we need to find is the price per sandwich. The price here is 8 cents. Well, we're going to have like 10-cent reductions in the price, so it'll be minus 0.10 times the number of 10-cent reductions. That'd be 0.10x. So this is our equation, or algebraic expression for the price per sandwich, 8 minus 0.10x. Now, there need to be some restrictions here, okay? And the restriction here is this. I'm going to put domain. We have to deal with things, we're dealing with price here. So we know price can't be negatives here, so we have to have 0 as the minimum. Now, Here's where you find maximum here. If I take that 8 minus 0.10x, set that equal to 0, and then solve for x, that means 8 is equal to, now move that that minus 0.10x over, it'll be 0.10x. Divide both sides by 0.10, you're gonna see, and if you do this in the calculator, x will be 80, okay? And it has to be, because if it was bigger than 80, then the price would be negative, which we cannot have. So that means here, the domain will have to be from 0 up to 80. So our domain is restricted from 0 to 80, including those two endpoints. All right, so now let's find the revenue for this. That's R of X. That would be, in this case, the number of sandwiches sold, which is this expression, 640 plus 20x, times the price, 8 minus 0.10x. Because revenue is going to be the number that you sell, times its price. All right, so now we got two binomials that we're going to need to multiply using the FOIL method. So let's do this. If I do 640 times 8, that would be 5120. The outer 640 times the 0.10x would be a minus 64x. Inner 20x times 8, that would be plus 160x. And then 20x times a minus 0.10x, that would be minus 2x squared. And if I combine like terms, this will be 5120 minus 64x plus 160x will be a plus 96x minus 2x squared. So that's my revenue function here, 5,120 plus 96x minus 2x squared. Now let's find the first derivative. Because we need our critical numbers, we need to determine whether we have a maximum or minimum. The derivative of 5120 is 0. The derivative of 96x will be 96. Minus the derivative of 2x squared would be 4x. So I have 96 minus 4x as the first derivative. And now, take r prime of x, set that equal to 0. And that would mean 96 minus 4x, 6 minus 4x is equal to 0. And if I subtract 96 on both sides, that would mean negative 4x is equal to negative 96, and divide by negative 4, that would mean x is equal to 24. So we know a critical number is going to be at x is equal to 24. Now, since we have restrictions from 0 to 80, we can just find what r of 0 is, r of 24 is, and r of 80. And that would give us our absolute maximum, since we have a restricted domain. Won't necessarily have to do the second derivative test here. R of 0, R of 80, and R of 24. Here, if you recall back in one of the previous sections when we were dealing with absolute maximum and absolute minimum, when you're given an interval, here you find out what the values are at your endpoints and at your critical numbers here. That's what we're going to do here. Let me go back up here. Okay, here we go. That's your R of X function. Each X value, we're going to replace these numbers in that R of X function, starting with R is equal to 0. Here's what we're going to have. Using this function where my finger is at, now I'm going to clear this calculator, you're going to have this 5120 minus 96 times 0 minus 2 times x, which is 0, and then squared. That would be 5120. Okay, and I think for 0, that's the easiest one to deal with these type of functions. For R of 80, using this R of X function here, it would be 5120 minus plus 96. And by the way, let me redo this one anyway, because this should be a plus 96, not minus 96. That would be 5120 anyway, because when I replace the x with 0, so probably wouldn't matter. But for 80, it would. So 5120 plus 96 times x, which is 0, and then minus 2 times x, which is 80, and then that's going to be squared. Sorry. X is 80. 5120 plus 96 times x, which is 80, not 0, and then minus 2 times 80, and then squared. That would give us 0. Okay? And now for R is 24, let's see, 5120 plus 96 times 24 minus 2 times x, which is 24, and that's squared. Here I get 6,272. Okay. Now the problem does say we're trying to maximize revenue. So here, the maximum would be the highest of these three. So it would be this number, 6,272, when x is 24. So at x equals 24, this is where I have an absolute maximum. X is equal to 24. And now we want to find out how much should the deli charge for a sandwich to maximize revenue. So we're looking for the price per sandwich. So here the price per sandwich if you go back up here, the price per sandwich, we found that out to be 8 minus 0.10x. 8 minus 0.10x, and x is going to be 24, so it'll be 8 so it'd be 8 minus 0.10 times x, which is 24. And I'll go ahead and do this in the calculator. 8 minus 0.10 times 24, that would be 5.6, or to 2 decimal places, $5.60. So to answer that question, the price per sandwich would be $5.60. So I'm going to go back up here. It'd be $5.60. So that represents the price per sandwich to maximize the revenue based on that situation. Okay. Now, part B says this. A different market survey shows that for every 20-cent reduction in the original $8 price, 5 more sandwiches will be sold. Now, how much should the deli charge in order to maximize the revenue. All right, so again, we're going to let X be the number of 20-cent reductions in price. Sold at X times the 20-cent reductions. That's the number of sandwiches. That's going to be, of course, 640 sandwiches that were sold per day. Here, 5 more sandwiches will be sold. So it'll be plus 5 times X. And then we want the price per sandwich. It's the original $8, then we're going to subtract from it 20 cents per sandwich that's being sold. 0.20 times X. Each sandwich will have a 20-cent reduction. Now let's find the domain for this one here. It will have to be 0 because in this case here, we can't sell negative number of sandwiches. But here, for this price, let's find out what the maximum X value it would be. So if I take 8 minus 0.20, set that equal to 0, it should be 8 minus 0.20x, set that equal to 0. This would be 8 is equal to 0.20 times x. Divide both sides by 0.20. This would be x is equal to 40. Okay, so the domain is going to be from 0 to 40. Okay. So if it's bigger than 40, that means that the price would end up being negative per sandwich, which we can't have. Now, my revenue function, again, that's going to be the price times the amount that I sell, the number of sandwiches that I sell. So the number sold is that 640 plus 5x. Oops. 640 plus 5x. The price per sandwich is going to be 8 minus 0.20x. And now we're going to use the distributed, actually use the FOIL method to multiply those two binomials here. All right, so in this case here, 640 times 8, that's 5120. And then 640 times a minus 0.20x, that would be a minus 128x. The inner 5x times 8 would be plus 40x. And then 5x times a minus 0.20x will be a minus x squared. And then if I combine like terms and put these terms in descending powers, I'm going to have a negative x squared. Minus 128 plus 40x will be minus 88x plus 5120. That's r of x. Now let's find r prime of x. The derivative of negative x squared will be negative 2x. The derivative of minus 88x will be minus 88. And the derivative of 5120 will be 0. Okay, so that's r prime of x. And then the next step would be to set r prime of x to be equal to 0. So that means I have negative 2x minus 88 equal to 0. And then to solve for x, in this case, add 88 to both sides. So that means negative 2x is equal to 88. But when I divide both sides by negative 2, I'm going to get x is equal to negative 44. Here's the problem. That negative 44 is not in this domain, 0 to 40, okay? So this is not going to be one of our critical numbers. So here, this is not in the domain. Okay, so we need to avoid using that. So the only thing we can use here are the 0 and the 40. So I need to find out what R of 0 is and R of 40 is. And that will tell me which one is going to be my absolute maximum. Okay, using this right here, I'm going to substitute each x with 0, that R of x function. And I might as well write this down as R of x here, here. So R of 0 will be this, negative x, which is 0, and that's squared, minus 88 times x, which is 0, plus 5120. And this gives me 5,120. And then R of 40, at the negative here, and then x will be equal to 40, so 40, and then that's squared, minus 88 times x, which is 40, minus plus 5120. That gives us 0. Okay? So the larger of the two would represent your absolute maximum, and it's going to be this 5120. So that means we have an absolute maximum at x is equal to 0. The absolute maximum is 5120, but it occurs at x is equal to 0. So now we can find the price per sandwich for this situation. And if you remember, the price per sandwich is that 8 minus 0.20x. And at x equals 0, we'll substitute that x with 0, so it'll be 8 minus 0.20 times 0. It's going to end up being 8 because 0.20 times 0 is 0. 8 minus 0 is 8. So the price per sandwich will still have to be $8. So to answer that question here, the deli should charge $8 for a sandwich to maximize the revenue. Okay. And finally, example 9. Here it is. A candy box is made from a piece of cardboard that measures 19 inches by 11 inches. So squares of equal size will be cut out of each corner. The sides would then be folded up to form a rectangular box. What size squares should be cut from each corner to obtain maximum volume? Okay, so now we're talking about volume in this case. And sometimes it does help to draw a figure of a rectangular figure, a rectangle. And so here's a rectangle that I'm going to draw here. All right, so there's a rectangular piece of cardboard measuring 19 inches by 11 inches. So I'm saying this is 19 inches, and this is 11 inches here. And you're going to have squares of equal size being cut from each corner. So in this case here, I'm going to do squares on each corner that are going to be cut out like this. Here's another square that's going to be cut out. Then another square will be cut out. and here's another square that would be cut out. Okay, and then they're going to be folded up to form a rectangular box. Now here's what we're going to do here. I'm going to let X be the side of a square that's being cut out. So in other words here, this side is X and this side is X. This is X and that's X. That's X and this is X. This is X and that's X. Now, we need to know something else. The volume of a rectangular solid. The volume of a rectangular solid, and I'm going to give this to you. This is length times the width times the height. Okay? The volume of a rectangular solid would be length times the width times the height. All right, so let's do this. Let's find out what our lengths are when those squares are cut off. All right, I'm going to take this length right here of 19 inches. Here, a length of X and a length of X is cut off. There are two X's that are cut off. So this length coming from here to here would be 19 minus the two X's that were cut off. That's 2X. That's the length of this remaining side. Now for the width, which is 11 inches, here, an X and another X that was cut off, that's two X's that were cut off. That means that this length right here ends up being 11, it's 2X. The whole 11 inches minus two lengths of X's cut off, 11 minus 2X. And of course, the height would just be the X itself when you fold that box up. So in this case here, the volume in terms of X would be that's the length, which is now 19 minus 2X, times the width, which is now 11 minus 2X, times the height, which is just X. When you fold that box up, that height would just have a length of X. Now we need to multiply this out. These first two terms, I'm going to use the FOIL method. So if I do this right here, 19 times 11, that would be 209. The outer 19 times a minus 2X would be a minus 38X. The inner minus 2X times 11 would be minus 22X. Last times the last 2X, minus 2X times a minus 2X would be a plus 4X squared. And I still have this X that I need to multiply. Now if I simplify this, this will be 209. Negative 38X and a minus 22X will be minus 60X plus 4X squared. Then that's going to be multiplied by X. Now I can distribute the X over the 209 minus 60X plus 4X squared. This will be 209X. X times minus 60X will be minus 60X squared, plus 4X squared times X will be 4X cubed. That is the volume that we're going to be dealing with. Now we're going to find the derivative of this volume. V prime will be this. The derivative of 209X will be 209. Minus the derivative of 60X squared will be 120X, and then plus the derivative of 4X cubed will be 12X squared. And then here I'm going to set that V prime of X, or V prime, to be equal to 0. And I'm going to put this in descending power, so this will be 12X squared minus 120X plus 209. That's going to be equal to 0. Unfortunately, there's no way I'm going to be able to factor that left side of the equation using into two binomials. The best way that I'm going to need to find out what x is to use the quadratic formula. Might have to refer back to chapter 1 in this series of videos, or if you've had college algebra, look at one of these sections in college algebra, and I believe it was section 1.5, that talks about the quadratic formula. That's this: x equals negative b plus or minus the square root of b squared minus 4ac. The whole thing is divided by 2 times a. That's what we're going to use here. And in this case here, it does have a 0 on one side, so I can identify a, b, and c. The a is the coefficient of your x squared term, that's 12. The b is the coefficient of x, that's negative 120. The constant term is 209. And I'll substitute a, b, and c into that quadratic formula. So that means here, x is equal to negative of negative 120 plus or minus the square root of b, which is negative 120, and that's square, minus 4 times a, which is 12, times c, which is 209. And all that's divided by 2 times a, and a is 12. So it'll be 2 times 12 in the denominator. And now we have x equals negative of negative 120 is a positive 120, plus or minus the square root of, if I square that negative 120, that's negative 120 times negative 120, that's going to be 14,400. 4 times 12 will be 48, times 209 would be 10,032. All that's divided by 2 times 12, which is 24. So now I got 120 plus or minus 14,400 minus 10,032 will be the square root of 4368. All over 24. And here I'm going to have 2 possible answers. X is equal to 120 plus the square root of 4368, 24, and then x is equal to 120 minus the square root of 4368, all over 24. And I'm going to find out what those values are to 2 decimal places. So here we're going to have this: 120 minus second x squared for the square root, 4368, and then I'm going to go ahead and press enter, but I have to divide that by 24. To 2 decimal places, that's like 2.25. Oh, I did minus. I did this one right here, down at the bottom. So that's 2.25. Okay. But let me do second enter. And I'm going to change this to a plus. That will tell me what that value is, but I need to divide by 24. That'd be 7.75, approximately. But one of these I'm not going to be able to use here. And the reason for that is, let's look at the 7.75. Let's go back up here. That width was 11 minus 2x. Okay? If I was to substitute that x was 7.75 in 11 minus 2x, this is what I'm going to have. 11 minus 2 times 7.75, I'm going to get a negative number. That means the width cannot be negative. So that means 7.75 cannot be used in this problem. So I need to eliminate that. 2.25 would be best to use because here's 11 minus 2 times 2.25. That'll give me 6.5. Okay? So my critical number will have to be 2.25. All right, now let's find the second derivative. So here I'm going to continue this down here to find the second derivative. The derivative of 209 is 0. The derivative of minus 120x will be negative 120, plus the derivative of 12x squared would be 24x. 24x. So v double prime, or the second derivative of that volume, would be negative 120 plus 24x. Now let's substitute 2.25 in for x. So this would be negative 120 plus 24 times 2.25. This will end up being, I'll go ahead and do this on the calculator as well, negative 120 plus 24 times 2.25, that would be negative 66. It's negative, so that means there's an absolute maximum. Since I'm only dealing with one critical value. So the absolute maximum would be 2.25, at x equals 2.25. So to answer the question here, a square with a side of a length of 2.25 inches approximately should be cut away from each corner to obtain the maximum volume. Okay. Because we're letting x be the side of a square. So that x value that would satisfy this will have to be 2.25 inches. Okay? All right, so that does conclude this video on section 4.6 dealing with optimization. And I do realize that this is kind of a lengthy video and there's a lot that I covered in this video. So hopefully this will assist you in completing the homework problems that are in my math lab. Feel free to reach out to me if you have any questions about any of the problems that were presented in this video or the homework problems that are in my math lab. Thank you very much.